Okay, guys, welcome back. In today's video, I'm going to do something that we did last week, which is Sunday, actually, least common multiple. And I'm going to do it differently. Um, and we're going to get into a little bit about code optimization and finding different ways to do things. So, this code should look familiar. It should basically be what I had last time. There might be some differences in naming conventions, but I think it's probably the same. So we go through finding all the prime numbers between 1 and 20. We raise those to the highest powers while still being below 20, and then we multiply those together. Now, as it turns out, the easy way to do this is just to do the array.reduce. So that's already one optimization that we can do. So if you do this, reduce A, B, B. The answer is right there in the console. So if I do, what's the upper bound on this that we've been doing? 20. This should still produce the same answer. I don't know. Oh, it's not. It's because I'm not the factors is what I need. Try that again, huh? Yeah. So there's the same answer. So that's one way you can sort of optimize your code, right? We're going to basically do something completely different than what we had here. So we're still going to have a loop, but that loop is going to go a lot quicker. So let's go ahead and multiple. We're going to take an array here. We don't have to take an array, but we're going to have an array of two numbers. One's going to be the bottom limit, and one is going to be the top limit. And the reason I'm doing it that way is because this is part of code that I wrote for when you have the lower boundary is not necessarily 1. So there's some extra stuff that you have to throw into that, which maybe I'll get to in the future. But you can make this work fairly easily without actually having to add any of that. So let's bottom. So what we have here is a ternary operator. If this is true, then bottom is going to equal this. If this is not true, bottom is going to equal that. And we can go ahead and okay, so and then we are going to create an array from those values. So how are we going to do that? Well, we're going to use the object constructor array minus bottom plus 1. So what we're putting in here is the size of the array, and the size of the array is going to include all of the numbers between the top limit and the bottom. So if I have the numbers between 1 and 5, I need 1, 2, 3, 4, and 5. So if I subtract the top 5, the bottom 1 from the top 5, that gives me 4. I need to count for 1 more. So that's an easy way to find it in our case right now. And in fact, if you had, if you were finding the least common multiple of the numbers between 13 and 18, 13, 14, 15, 16, 17, 18, that's 6. 18 minus 13 is 5 plus 1, 6, right? So that's the same way you would do it there. So that's only going to create an array where each is undefined. If you do .fill, it is going to produce them in order from 1 or from 0 to whatever. So the first one's going to be 0, etc., etc. But we don't necessarily want to do that. So we are going to do .map x I. We're going to return I plus bottom. So what this does is it changes the value of each item in the array to where am I getting missing something right there. It's going to if you have an array like 13 or whatever to 18, the bottom is going to be 0. Once we add the bottom, it's going to be 13, and the next one is going to be 1 plus bottom 14, right? So it's an easy way to sort of fill out an array of continuous numbers or contiguous. So for let I 0 is less than length I plus plus or I minus 1 j greater than or equal to 0 j minus minus. Okay, so in the first loop, we're starting at the beginning, and we're going through each number in the array. In the second, we're going through all the previous numbers in the array, and so we're going to start out at the first one. It's going to get skipped immediately because the first one doesn't have any numbers less than it. In the second instance, it's going to go to the second number, and then it's going to check the first number, and then it's going to stop. In the third instance, it's going to check the third number, then it's going to check it against the second number and the first number. Now we're going to go over what it's actually checking for. So if nums I by nums j. Oh, sorry. It needs to be equal to 0. ID is if. Then that value at nums I is going to be equal to nums I divided by nums j. So this is the part that only works for a continuous set from 1 or 2 to an upper bound. It wouldn't work for anything that has a lower value that's more than greater than 2. I suppose except in instances where the entire set is just odd numbers than 3, right? But it does work in this instance. So what's going on? Let's say we have the number 20. Well, it's going to keep on going down. It's going to stop at 10 because it's going to say, well, 20 divided by 10 is actually there's a 0 remainder there. So we're going to take 20 and divide it by 10, and we're going to return 2. And then, I mean, most of the 2's are going to be caught by this point, not all of them, but let's presume the number 2 hasn't gotten caught yet. And we're going to say, okay, now we're at, our 20 is now worth 2. It gets around to 2, and it says, oh, actually, as it turns out, those are divisible by each other with a remainder of 0. So we're going to take the 2 that was in the 20 spot, divided by 2. Now it's 1. The 2 that's originally there, though, keep in mind, that's still there. So what's going on here? So when you get around to something like 4, that's going to turn into a 2, because once it gets checked against 2, it gets turned into 2. 8 is going to get turned into 2 also, because it's going to get to that 4 that's a 2. It's going to get turned into 4, and then it's going to get to the 2 and get turned into 2. 16 is going to get turned into a 2, because it's going to get to that it's going to get to that 8 that's now a 2 and turn into 8. It's going to get to that 2 that was a 4 and become a 2. Yeah. So it's going to get to the what was a 4 and is now a 2 and turn into a 4, and it's going to get to the 2 and turn into a 2, right? So as we saw in the previous video, at the end of it, we have 4 2's times 2 3's times 5 times 7 times 11 times 13 times 17 times 19. And that's our answer. So all the other 2's are going to get excised. In fact, 20, it's going to get divided by 2 at 16, because by that point, 16 is 2. And then it's going to get divided by 10 once it hits, it's going to get turned into 2 when it gets to 10, because 10 is going to be a 5 at that point, and then it's going to turn into 1 when it gets to 8, because 8 is a 2 at that point. So, we can go over other examples, right? Because 10 is going to be a 1 at that point. So 15, right? It's getting divided by the 5 and the 3. That's going to be a 1. So what are we returning here? We are going to return nums.reduce, just like we saw before. Times b. If you don't know what the reduce function is, I would suggest going and checking that out, looking it up. Smallest multiple. And we've got to pass in an array. Let's pass in 120. The exact same answer. We've got to scroll up a bit to find it again. 232792560. 232792560. Same answer. And I took this little snapshot of running it in my terminal before. This is how long it took for the first one that I showed you guys on Sunday. This is how long it took for this one that I just showed you now. That's a lot faster. Why is it a lot faster? Well, even though we've got two for loops here, this for loop is actually there's not a high end value on it, because in the first instance it's only going through 0 times. In the last instance, it's going through the full set. It doesn't end up being O of n squared. It ends up, I think, being O of n times log n, I believe. But I might be wrong on that. Still relatively fast. And then, contrast that with what we had before. Let's just pull that up again, and then I'll go ahead and copy and paste that over here. Well, we've got this we've got this. Uh, we've got quite a few loops going on here. This probably not too big of a difference from a reduce, frankly, but uh, we've got a lot of different loops that we're going through here. And I've eliminated those. So that's a big reason why it's so much faster. Now, you probably wouldn't notice this huge of a difference um, on larger numbers. It might turn out that it's not that as big of a difference. Might also be the complete opposite, where the difference is magnified even more. I don't know. We can go ahead and try that. Um, let's go ahead and try something like 100. Run that. Oh, that's big. Um, you try it on my terminal. The big problem is that something like this might end up being a big int, So go ahead and try it. Yeah, it's still much faster when you do 100. It's the top one ended up not changing too much. It's still about 4.9 it's 4.9 seconds, and the bottom one actually did increase dramatically. It's now 0.627 seconds. So I'm sure the difference, like I said, would actually go down over time, because we're only these improvements are really only seen at a small scale. But still, it's something to keep in mind when you're trying to optimize code, to look at things that um, can go a little bit faster. This code's obviously much longer um, than this. This is incredibly short. It's much faster. No reason to prefer the other one over this one, frankly. So I hope you guys found that informative. Drop a like. Let me know what you thought, and yeah, I'll see you guys